Hey class. Now let's start with exponential functions. We in another chapter now. We're in chapter 4, and we're doing exponential functions. Okay. So the first thing we're gonna go over is a couple of exponential rules, like rules for exponent or properties for exponents, and then from there we're gonna go more into exponential forming, and I'm gonna talk more about that for you. Now, look what it says. Additional properties of exponents. For any real number a greater than 0, a cannot equal 1. The following statement holds true. A raised to the x is a unique real number. Okay. For all real number x. What do we mean when we say that? Here is what we mean when we say it over here. Our description. You see the part that says description? What it's saying is y equals a raised to x can be considered as a function, right? If y equals a raised to the x is considered a function, then we can say f of x equals a of x. Remember, y equals f of x with a domain of negative infinity to positive infinity. That means any real number. Your domain for x is any real number. Okay? So the property for a, I am just breaking down what it actually means. We're trying to break it down more so you can understand the description of it. Okay? So if a raised to the x is a unique real number for all real numbers x, then we can say f of x equals a of x with a domain that is negative infinity to positive infinity. Okay. Now, let's go to property B. Because property B is going to be the property we use to solve these exponential equations soon. Okay. Once again, property B is what we will use when we are solving these exponential equations later in the section. So we're going to highlight that, property B. That's the one we're going to look at. And we're going to also star it because you're going to see this is going to come back again. Okay. Look what it says. A raised to B equals A raised to C if and only if the exponents are equal. If you have two base that are the same raised to different powers and they're equal to each other, you can set the exponents equal to each other. Okay? So our base here would be A. Look, A is our base. A is our base here. Here's our exponent for this base. Here's our exponent for this base. Well, since they are the same base, we can set the exponents equal to each other. So there we can say here that B equals C. That's what we can say here. Right? So what does that mean? It means that f of x equals a raised to the x is a one-to-one function. That's what it is a one-to-one function. Okay. The next property we have, right? If a is greater than 1 and m is less than n, then the following is true. A raised to the m is less than a raised to the n. Okay? So if a is greater than 1 and m is less than n, then we can say a raised to the m is less than a raised to the n. Now, let me show you what I mean by that. So you see the concrete example we have right here where we say 2 to the third is less than 2 to the fourth. Okay? 2 to the third is 8. 2 to the fourth is 16. So that is correct. We proved that, right? So what it also is saying, it says increasing the exponent leads to a greater number, right? Because we got the concrete, greater number. So therefore the function f of x equals 2 raised to the x is an increasing function. Okay? It gets bigger. Your f of x gets bigger There you go. Now, the next thing. FA is between 0 and 1, and M is less than N. A to the M is greater than A to the N. Let me say it again. If your A is now between 0 and 1, and M is less than N, then we can say that A raised to the M is greater than A raised to the N. Okay? Now look at the concrete example we have here. 1/2 raised to the second, 1/2 raised to the third. Okay? 1/2 raised to the second is saying 1/2 times 1/2, which gives me 1/4. And then 1/2 raised to the third is saying 1/2 times 1/2, 1 times 1/2, which gives me 1/8. 1/4 is bigger than 1/8. So increasing the exponent leads to what? A lesser number, right? Or you can say smaller number. The function f of x equals 1 over 2. 1/2 raised to the x is a decreasing function. Okay? So just trying to give you some properties before we get into all the way of exponential. Now, like I said, property B is what we're going to use to solve our exponential equations later in the section. So now let's go on to exponential functions. Look what we have here. Okay. This is the form of an exponential function right here. This is the form of an exponential function right here. A is our base, x is our exponent. A is our base, x is our exponent. And your base has to be a number, real number. Okay? And A is going to either be greater than 1, or A can fall in the category of being between 0 and 1. All right? A is our base. A is a real number. A is either greater than 1, or A is in this category right here, which is between 0 and 1. Now, x here is an exponent. X is considered the exponent here. Okay. Please understand that an exponential function will not have a variable as a base. So let's make a note of that. A variable cannot be, the base cannot be a variable. Your base cannot be a variable. It has to be a positive number. Okay, and it says a real number, but it has to be a positive number. And I should say it should have to be a positive real number. Okay, it can be greater than 1, or it can fall between 0 and 1. The numbers that fall between 0 and 1 are fractions and decimals. Okay, your exponent can be negative or positive. Just depending on what you have. But your base has to be positive. Okay? These are the facts that we know about an exponential. Now, the next thing. This is where you take out your calculator and do. And this is just practicing using your calculator, knowing how to type these in. Okay? Knowing how to type these in. First part. We evaluating exponential function. Evaluating exponential functions. Here's my function right here. F of x equals 2 raised to the x. 2 is my base, x is my exponent. And this, when we finding this function value, because that's all we're doing is finding function value, we are putting this number you see in parentheses here. These are your x values. right? That's the value you got to plug in. But your x is an exponent. So when you do it on a calculator, you got to make sure you put it in correctly. You raise it to a power. So let's do it. Okay. We're going to do f of -1. And look at my function. My function says 2 raised to the x. So I'm saying 2 raised to the -1. And I can do this without a calculator because you all got to remember negative exponent. Negative exponent does not mean the answer is negative. It means that your answer is going to be a small number. So when you have a negative exponent right here, all you got to do is flip this. Make it 1/2. And when you make it 1/2, your exponent becomes positive at the bottom. And that's what we want. We want positive exponent. We do not want negative exponents. So this is my final answer, 1/2. The next thing, let's do the next one, f of 3. Well, f of 3 here means that I say 2 raised to the third. And if you put 2 raised to the third in the calculator, you will get 8 here. So our function value for this is just 8. The next one, f raised to the 5/2, right? Now I really have to use the calculator now because I don't know what f raised to the 5/2 is. So I'm saying 2, and then my exponent now is 5/2. Look, I got to type it in. Now, let me break out the calculator real quick for you all so we could type it in, right? So you can see me typing in. So I start off with 2. Now, right here, remember my exponent key right here? For you all, if you're using an older calculator, this symbol will come up and then you can write your exponent. But if you looked on my calculator right here, it moves the cursor to the exponential and the exponent position so you can write it there. So I'm going to put mine in parentheses since I got a fraction. I would put it in parentheses, you all, and do it like that. Close my parentheses, and all I have to do is press enter, and it gives it to me. Okay, and my direction says round to the nearest thousandths, and the nearest thousandths is 3 places after the decimal. Okay, so we'll take the second 6, look at the 8, and move that second 6 up, right? So here you all, I get, let me double check. What do I have again? 5. Just make sure I'm writing it right. 5.657. That's what I would have. Because I'm rounding to the nearest thousand. Your thousandths is 3 places after the decimal. Okay. Now, the last one, I'm taking f of 4.92. Right, finding that, you raise 2 raised to the 4.92. Gotta put this in the calculator. Come back, put it in the calculator. Let's do it. 2. Once again, I hit my exponent key. You gotta see how your calculator work. And then I just put this in because it's already raised to that power, and it gives me 30.23. And I look at that 3, and that 8 determines that my 3 moves up to a 4. So 30.274. Now, this is the end of the first part.